Hey guys, in this video I'm going to explain stress strain curve. So as you can see here the graph, and we'll take x-axis as strain and y-axis as stress. As you can see here, OA, which is a straight line of the graph, indicating that stress is directly proportional to strain. And up to point A, Hooke's law is obeyed. And what's the Hooke's law? That under the limit of proportionality, stress is directly proportional to strain. So till here from O to A, Hooke's law is also obeyed. At point A, this point is called proportional limit. This point O is called proportional limit. And in this reason, the wire is perfectly elastic from O to A. Wire is perfectly elastic, means if we stretch any wire, if we apply any force, deforming force, then the wire will be stretched, but after removing the deforming force, the stress will be negligible, and that will become again its original position, means initial position whatever the wire have. So after the point A, the stress is not proportional to the strain. As you can see, a curved path is here from A to B. So from here A to B, this is done. Stress is not directly proportional to strain. However, the load is removed between point O to B. Still, you can say, however, if the load is removed at any point between O to B, then the curve is retraced along OAB and the wire attains its original position. And the portion this O to B is called, the graph is called elastic region, and the point B is called the elastic limit or yield limit. This point is called elastic limit or yield point. And the stress corresponding to B is called yield strength. This is called yield strength. And here, beyond point B, the stress increases more rapidly. As you can see here, the strain is increasing more rapidly than stress. And if we remove the load, then also at the point C, if we remove the load, then the wire does not come back to its original position. Means the elasticity is gone. Now no more elastic. Even reducing the stress to zero, if we reduce the stress to zero, a residual strain equal to OE is left in the wire. And here the material is said to have acquired a permanent set. This is permanent set. And now if the load is increased beyond point C, then there is a large increase in the strain. As you can see, large increase in the strain of the wire. In this reason, the constrictions called necks and waists develop at few points along the length of the wire, and the wire ultimately breaks here at point D. The wire breaks at this point, at D. And this region is called fracture point, as here the wire breaks. And the reason between the reason between B and D, the length of the wire keep on increasing without any load. Even the load is not applying, but still the length is increasing from B to D. And this reason is called plastic reason, or you can say the material is undergone the plastic flow, or you can say plastic deformation. And the stress corresponding to the breaking point is called ultimate strength. This stress corresponding to the breaking point is called ultimate strength, or you can say tensile strength of the material. So this we have learned in this stress strain curve. Okay, thank you.